Hold a compass in your hand and the needle feels like a fact, something fixed, pointing at a place that never moves. It isn't fixed. The magnetic north your compass hunts for has wandered hundreds of miles in your own lifetime. And the field producing it has flipped completely, pole for pole, hundreds of times in Earth's history, north becoming south and south becoming north across thousands of years each time. It's doing something unusual again right now, and nobody can tell you exactly where it ends. None of that comes from a bar magnet buried in the core. Almost the entire field is generated nearly 2,000 miles down, where a shell of molten iron churns around Earth's solid inner core. That moving metal carries electric current, and the planet's own spin twists that current into a self-sustaining loop called a geodynamo. Turn off the churn and the field would fade within 20,000 years. It has never turned off. It has, however, flipped. That field isn't decoration. It extends far past the atmosphere into a magnetosphere that deflects the solar wind and most galactic cosmic radiation before it ever reaches the ground. Weaken the field and more of that radiation gets through, mostly as more auroras and more static in satellite electronics. It's a shield, not a light switch, and understanding what happens when a shield gets thin is the whole story here. Now the historical record. Geologists read the direction of Earth's field frozen into cooling lava and layered sediment going back hundreds of millions of years. And it shows the poles trading places again and again, on average every 200,000 to 300,000 years, though real gaps between reversals swing wildly, from 10,000 years to tens of millions. The most recent full reversal is called the Brunhes-Matuyama event. In 2020, a team led by Yuki Haneda at Japan's National Institute of Polar Research dated it precisely using a sediment core from Chiba, Japan, the site that later gave its name to an entire geologic age. Their result? The field became unstable at least 10,000 years before it flipped, and the full transition, unstable start to settled finish, took at least 20,000 years. This was not a switch. It was a slow, messy unraveling. It's not the only kind of magnetic event in the record. Sometimes the field starts to flip, weakens dramatically, and then snaps back to its original orientation instead of completing the reversal. A false start rather than a finished flip. Geologists call this an excursion, and the best dated one sits at around 42,000 years ago. The Laschamp event, first identified from lava flows near Laschamp, France. In 2021, Alan Cooper's team at the University of Adelaide, publishing in Science, used ancient kauri trees preserved in New Zealand bogs to date it with unusual precision. During the roughly 800-year Laschamp event itself, the field dropped to about 28% of its normal strength. In the run-up they called the Adams event, it briefly collapsed to somewhere between 0 and 6%. For a few centuries, Earth's shield was barely there. A 2024 follow-up in Science Advances modeled what that would have looked like from the ground. The field, near 10% of today's strength, multiple weak poles wandering away from the geographic poles instead of one clean axis, and aurora, normally an Arctic curtain, visible near the equator for roughly 2,000 years. The kauri trees also recorded a spike in radiocarbon, the signature of cosmic rays flooding an unshielded atmosphere. Cooper's team went further, and this is where it gets genuinely contested, not just uncertain. They proposed the Laschamp collapse triggered a global environmental crisis, shifts in atmospheric ozone and circulation, changes in animal behavior, even a role in Neanderthal decline and the extinction of megafauna happening around the same window of time. Other researchers pushed back hard. John Hawkes, a paleoanthropologist at the University of Wisconsin-Madison, published a direct rebuttal in Science, arguing the team had misread the very extinction and cultural data they cited, and other critics called the timing match, at best, coincidental, since the archaeological and genetic records don't cleanly support a Laschamp-driven collapse. Correlation across a few thousand years of prehistory is not the same as proof of cause, and right now this one stays open. Zoom out to the full record and the picture gets calmer. The United States Geological Survey states it plainly. There is no established statistical correlation between magnetic reversals and mass extinctions. Reversals happen roughly every million years on average. Genuine mass extinctions are far rarer, and when researchers line up the two timelines across hundreds of millions of years, they mostly don't match. Even the Cretaceous-Paleogene extinction, the asteroid that ended the dinosaurs, shows no associated reversal at all. One narrow exception keeps surfacing in the literature, a rough overlap between the end Triassic extinction and a stretch of unusually frequent reversals during a period of low atmospheric oxygen. But researchers who've studied it call it the only clear case in the entire record. And not a strong one, next to far better supported culprits like asteroid impacts and continent-scale volcanic outpourings. So the deep past says, uncomfortable weather for life, not doomsday. Which brings the story to right now, because Earth's field isn't just sitting quietly waiting its turn. Over the South Atlantic, satellites have tracked a patch of unusually weak field for decades, called the South Atlantic Anomaly. Using 11 years of data from ESA's swarm satellites, a team led by Chris Finlay at the Technical University of Denmark found the weak patch has grown by an area close to half the size of Europe since 2014, and its weakening has sped up since 2020. A second low-intensity center has now appeared southwest of Africa, suggesting the anomaly may be splitting in two. It sounds like a warning sign, and satellites flying through it do take more radiation hits. But Finlay's own team was direct about what it isn't. This doesn't indicate an imminent full reversal. It reflects ordinary turbulence in the molten outer core, flow patterns that can shift the surface field within a matter of years, with or without heading toward a flip. The compass itself is racing. Magnetic north crept along at 9 to 15 miles a year for centuries, then accelerated hard through the 1990s and 2000s toward Siberia, hitting a peak of roughly 50 to 60 miles a year. Researchers at the University of Leeds traced the cause to two competing lobes of magnetic flux deep under Canada and Siberia, one stretching thin and losing its grip. Then, after 2020, it did something nobody forecast. It slammed on the brakes, dropping to about 35 miles a year, the sharpest deceleration ever recorded. Add it up, and the field measured today is about 9% weaker than it was in 1840. Part of a decline some satellite analyses now clock at 5% per decade, rather than the historical 5% per century. Nature Communications traced the likely cause to a slow gyre of molten iron, pulling normal polarity field toward the equator, while patches of reversed polarity, tied to that same South Atlantic weak spot, keep spreading and eating into the dipole's overall strength. And yet, a separate study in the Proceedings of the National Academy of Sciences looked at the same decline and argues the field's overall shape still looks like one that recovers on its own, the way it has recovered from smaller dips before, not one mid-collapse toward a full reversal. Two well-credentialed groups reading the same churn in the same molten core, and neither can currently tell you which of them is right. So the compass in your hand is quietly recording the leading edge of a process too slow for any one lifetime to see finished, in a shield that has come apart and rebuilt itself hundreds of times before you existed, on a planet that kept spinning and kept its molten heart churning through every single one. And every time, something was still standing on the other side to build a new compass. Whatever this current stretch of weather turns into, that part of the pattern hasn't broken yet.